And number 4 says to graph the function f of x equals 1 over x. Now this is what we call the reciprocal function. It's 1 over x. And we know that for this to be a function, or our domain, x cannot equal 0. So my domain would be the set of all x such that x does not equal to 0. Alright, I've already written out a few XY charts or function value charts. You may want to take a minute just to look at each one of these. I'm going to start with the first one here. Okay, what I did was I've supplied the x values and I plugged those into the function. Okay, so it's just a matter of taking the reciprocal. So if I plug in a -1, the reciprocal of -1 is still -1. If I plug in a -0.5, you think about this is negative 1/2 in the denominator, the reciprocal would be -2. If I plug in -0.1, it's going to be -10. -0.01, the reciprocal would be -100. Okay, so I'm going to plot just those 4 points first, okay, to see what this graph looks like. So I would have -1 would be about here, -0.5 and -2 would be here, and these are really close together. -0.1 would jump down to -10. Okay, it's getting really close to that y-axis. -0.01 it would be way down at -100. Okay, so I have a curve that looks kind of like this. But what's happening to it as it goes down, as this function goes down? It's getting closer and closer to this line x equals 0. Okay, so we say, if you look at the statement I have down here at the bottom, as x approaches 0, okay, my values got closer and closer to 0 here. From the left, that means from the left part of our graph, the function values decrease without bound. So the notation for that we can write is that we can say as x approaches 0, we use a little arrow, as x approaches 0 from the left, I put a little negative sign. That means from the left. If it was from the right, I would have a plus sign. As x approaches 0 from the left, the function values f of x approaches, or they decrease without bound, approaches -infinity. So this is just some terminology and some notation that we can use to describe this graph. Okay, look at the second set of values I have here. And these may be also a little bit hard to see on my graph, but if my x value is 0.001, so that would be positive 0.001, it would be positive 1,000, so way up off my graph. 0.01 would be at 100, way up here again. 0.1, the x value is 10. 0.5, my x value is 2. And 0.1, or 1, my x value is 1. So again, I have this curve looking like this. So for my notation, I would say, go back down here to the bottom, as x approaches 0 from the right, it's coming in from the right, approaching 0 for the x value. F of x approaches positive infinity. So my notation for that would be as x approaches 0 from the right, I put a plus sign, f of x approaches positive infinity. Okay, for the other values I have, what's happening to x here? A 1, 10, 100, 1,000. X is approaching infinity. X is getting larger. What's happening to my function values? Well, as x gets larger, and if I come out here to, we already have the 0.11, 10 would be 0.10, 0.1, and if I could go out further, those function values are approaching 0. Okay, so I have down here, as x approaches infinity, as x gets larger, f of x is going to approach 0. Okay, And I can do the same thing as x approaches negative infinity. That's the values I have here. These are getting larger in a negative sense. My function's also getting closer and closer to 0. Okay? So this would be the other part of my graph going this way. So what I want you to see is what the shape of this reciprocal function looks like. And then we'll use that. This is kind of the parent graph for 1 over x. And we'll use that to graph some transformations of this function.